To describe two-dimensional motion, you require two coordinate axes. One is the vertical axis and another is the horizontal axis. The horizontal axis is usually taken as x and the vertical one is taken as y. You can take it other way around also. Okay, it doesn't matter. Now, but usually we will prefer this, that horizontal axis is x and the vertical axis is y. Now, if I have any particle which is present here like this, okay, then the particle's position will be having two coordinates, right? One is this y coordinate and another is the x coordinate. So it has two positions, okay, sorry, two coordinates which are x and y. So if I know the x coordinate and the y coordinate of the particular particle, then I can locate the particle in these two dimensions. Okay, so I need these two numbers. Okay, now to do that I can define a vector. Okay, so I can define a vector which is from this origin O to this particular particle. Now this vector is also called as position vector. Okay, so that describes the position of particle. So this describes the position of particle. Note that it is only in two dimensions now, as of now. So this vector I will denote it as r bar vector, where r is the distance, or you can say r is the position vector of this particular particle with respect to this origin. Okay, now this is one particle r bar and it is position. Now suppose this is initial position, right? This is r1 bar. So I will take initial position as r1 bar. So initial position is r1 bar. This is r1 bar vector, and after some time, okay, it follows a certain trajectory and it goes from this particular point to another point. Okay, and here its position vector becomes r2 bar. So I will denote it here by again a vector. So this is the vector r2 bar. So let me use yellow pen. So this is r2 bar. Now this is the final position. Okay, suppose this when the particle was at the position r1 bar, the time was 0. Okay, t was 0 seconds. Okay, the time that the observer was measuring, or time the observer started taking the time at this particular instant when the particle was at this point, and when the particle moved here, the time was suppose t. Okay, so only t amount of time passed through such that it moved from this position to this position. So in time t, what will be the displacement? Displacement will be change in the position. Okay, so the displacement vector will be this vector. Okay, this straight line vector. So I will show you with the white vector like this. This vector which starts from this position and ends at this position is displacement vector. So I am denoting it as S bar. Okay, but now here you can see from triangle law of vector addition, I can say that R1 bar plus S bar, R1 bar plus S bar is equal to R2 bar. Okay, so the displacement vector is S bar. I will write here displacement vector S bar. So we are finding what is the displacement vector. So the displacement vector is S bar is equal to R2 bar minus R1 bar. So this is the displacement, okay, which is taking place in this case. Now if I find out R2 bar and R1 bar in terms of coordinates or components, okay, I will write this as, again I will write here S bar as R2 bar minus R1 bar. But before we do that, you can see from here that the displacement vector is nothing but the change in the position vector. Okay, R2 bar minus R1 bar, that is final position vector minus initial position vector. So in two-dimensional motion, this is the formula for displacement. Okay, now if I write it in terms of components, okay, so this is S bar, okay, so R2 bar can be written as X2 I cap plus Y2 J cap. I am writing it into component form. R1 bar can be written as X1 I cap plus Y1 J cap. Now what is R2 bar minus R1 bar? The displacement is R2 bar minus R1 bar, which is equal to X2 I cap plus Y2 J cap. We get this X2 minus X1 I cap plus Y2 minus Y1 J cap. So this is the displacement. So the displacement over here is the change in the position coordinate or the change in the X coordinate plus change in the Y coordinate. Okay, J cap and I cap are multiplied with each other, so not each other, multiplied with this corresponding terms. Okay, this is multiplied with I cap, this is multiplied with J cap. Now this you can see that if I say the displacement is in one dimension, if I see the displacement in one dimension, suppose a particle was here, okay, this is my origin, and it was here when the time started x1, and after some time it was at x2. The displacement will be x2 minus x1. Okay, now suppose I had y-axis also, it was here initially y1 and after some time it went here y2. So here the displacement will be y2 minus y1 like this, and here it is x2 minus x1. So it is same as that of the one dimensional case, except that there are two dimensions, I cap and j cap. Okay, so there are two directions, sorry, I cap and j cap. So the displacement is written like this, and the magnitude of the displacement will be given by the magnitude of S bar vector, which is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the distance between the two coordinates. Okay, so if I have these two coordinates as x1 y1 and this has x2 y2, then you can directly say that the displacement will be x2 minus x1 whole square plus y2 minus y1 whole square. This is the case, and which is under square root.